Alright, so hello and welcome to the 0478 Computer Science series. And in this series, we are going to be going through the entire syllabus, for the the 0478 IGSC Computer Science for the Cambridge International Exams. So without further ado, let's actually jump in and see what we have in store. So before we actually get started, we first need to look at the fundamentals of computer science as a subject, as it were. So we'll start with a primer, then we'll pick up from topics 1 through should be topic 10, I believe, for the IG series. So yeah, let's get right into it. So we are going to be looking at what computer science is, and also why we study CS, as well as looking at the basic components that make up a modern computer system. So what is computer science? So computer science is the study of computation, information, and automation. So essentially, computation, it's whereby we are talking of calculations, and if you think about it, for the most part, the data that we work with, let's say you are taking a photo or you are typing a document, essentially there is some sort of calculation going on, as it were, as you shall come to realize, or as you shall come to appreciate as we proceed with the course. So information is everywhere. Like for instance, we store a lot of information every day. We store music, we store documents, we send email, we store movies, we store pretty much everything that we interact with on a day-to-day basis forms information. And also with CS, we are looking at how we can automate some of the processes. Like for instance, you might want to automate how you send information, right? Let's say you wanted to send an email at a later time. You could actually write a script that can automate the sending of email, and also you can write programs that do pretty much repetitive tasks much more quickly, and essentially that's the essence of automation. So with CS, we are also looking at the theory, the design, the development of software, of hardware, as well as algorithms. And for the most part, we are going to be looking at the interplay between software, hardware, and algorithms, which is why you'd find out that for the P1 you get to write something called computer systems, and for the P2 it's going to be problem solving and programming. It's actually problem solving, programming, and logic. So yeah, that's the whole essence of those are the three pillars of CS as a subject. Then also, maybe let's just take a look at the table that we have going on here. You see that we have some areas, then some examples of some of the things that you'll be looking at in that particular area. Like for instance, in the area of algorithms, we are looking at procedures for solving problems, and for the most part we are going to be dealing with sorting and searching when you talk about algorithms. And then we also have data structures like arrays. We also talk about programming. We'll be looking at programming languages like Python, like Visual Basic, like Java. Then we're also looking at computer systems when you're talking about hardware, low-level hardware, CPU architecture, and so forth and so on. So we'll also be talking about AI, networking, and databases as we progress with the syllabus as it were. Then the reason why computer science is important is that it allows us to solve problems. It gives us a way to innovate. It gives us, of course, the obvious one, there is career opportunities like software engineering, data scientists, cyber security. Right? You can actually develop a career, or you can have your career stem from the CS subject, as it were. Then you can go on to specialize in vast majority of areas that you can choose to go any path that you choose from, that branches from the subject as it were. Then also nowadays it's really important that you study something like CS, because of the interplay or the interdisciplinary applications of CS as a subject. So you realize that even if you are in medicine, you are going to be making use of automated or automation rather is it. So there's a lot of machinery that you'll be using, like electronic machinery like MRI scanners, life support systems is it. You realize that for the most part such systems are making use of a computer, so it's really beneficial that you understand the essence of CS as a subject. Then let's go ahead and take a look at what comprises or what constitute a modern day computer system. So here on this diagram you see that rather on this graphic you see that we have a couple of things going on here. So I'm not going to read all of them because I think we'll be looking at them in more detail as we progress. So you realize that for the most part if you have a desktop PC, you are going to need a computer case, right? So the computer case is going to house all the other components that you are going to build your computer system with. Then inside of the computer case you are going to need a CPU fan, which is going to provide a way for the computer system to cool down. Because remember that rather you come to realize that when a processor is running, it's drawing power from either the battery or from the power supply unit as it were. So as it is doing that work, it's going to generate a lot of heat, and that heat needs to be dissipated or it needs to be dispelled from the computer case as it were. So that's why we need to make use of the fans. Then the motherboard, that's where all the other components are going to connect. So essentially it acts like the nervous system of the computer, is it, much like the spinal cord to us human beings. So you realize that the spinal cord, that's where you have all the neurons connecting, right? So in much the same way as we have the spinal cord, we have the motherboard or the system board as it were, and that's where we are going to connect all the components that we are going to be making use of to build our computer system. So we are looking at things like the CPU. We are looking at such things as the hard drives or the solid state drives as it were, and all the ports that allow us to connect components or peripheral devices. They are going to be connected via the motherboard. Then you can actually see from this graphic here that on this end right here where my mouse is hovering, you can actually see or pick out some ports that you'd actually connect peripheral devices to the computer system as it were. Of course, the CPU is the brains of the computer. It's going to be doing all the processing, and central is the name, central processing unit. Again, we'll be delving deeper into what makes or rather what constitutes the CPU. Then of course there's the CPU fan. This one is dedicated specifically to the CPU because it's going to aid the cooling. Remember we mentioned about CPU fans earlier, but we also make use of the CPU fan, which typically sits on top of the CPU so that it helps the CPU keep cool. Then of course any computer system is going to need a power supply unit, right? So the power supply unit is essentially going to receive power from your outlet, and then it's going to distribute that power to the components on the motherboard or the computer components that make up the computer system. Then you realize that for the most part computer circuitry typically works with direct current, is it, whereas the power or the electricity that comes from the mains is alternating current or AC. So essentially the power supply unit is just going to translate or change your electricity from AC to DC, and it's also going to step down the voltage so that it's not excessive. Like for example, a household or the domestic AC is usually 230 volts. That is for the UK standard, right? Then for the American standard, I think it's 110 volts. But for the UK standard, it's around 230 volts. So you realize that that is too much voltage for the components that are inside of the computer system. So we need to have that converted to a lower voltage, typically 12 volts to around 5 volts. Then so that's where the power supply unit comes into play. Then we'll also be talking about random access memory, which is essentially the working memory, right? As your program is running, it's going to need to reside in memory. Then we'll actually be looking at the differences between the differences amongst the various kinds of memory that you encounter in a computer system. Then another important concept is component is the graphics card, which essentially is going to process the visuals that you see on your computer system. Again, we will be looking at that in more detail as we progress with the course. Then remember, we said that RAM, we said this is working memory, right? Then obviously you need permanent memory, something that you're going to store your information permanently. So that's where hard disk drives come into play. There's also solid state drives that you can make use of with to store your data, as it were. But then again, don't worry about it. We are going to be looking at that in more detail as we progress with the course. Then optical storage, which is becoming less and less common, but it's still another type of storage that you should we'll be looking at, right? We'll be looking at that in more detail. It makes use of CDs, DVDs, and Blu-ray discs for the most part. So yeah, I think that does it for the primer. So this was just an introduction to the as an overview to the course. So we'll be diving deeper, looking at each topic one at a time, and I think that's just about it for this video. I'll see you in the next one.